Good morning, students. Welcome back to Digital Electronic class. In today's class, we are going to continue the previous concepts what we have discussed, like combinational circuitry, the combination of the inputs what we do have, and how we are going to convert into particular output, and all the types of various combination of inputs we are going to deal. And today's class, we are going to start the basics of our flip-flops. So in today's class, I'm just going to give a brief introduction regarding the flip-flops. Before proceeding with that, let us take a previous class overview what we have discussed in the previous class. In the previous classes, we have talked about the combinational circuitry, the full adder, full subtractor, half adder, half subtractor, and various type of input combinations. All these particular things we have discussed in the previous class. Okay, so in today's class, we are going to continue the concepts of sequential circuit. So basically, what is a sequential circuit? Sequential circuit is also like a combination circuit where it is going to take different input combinations and try to produce the output of it. So in that, the basic things of the sequential circuit would be it has some memory elements. So what is that memory element? So basically, memory elements over here we are considering to be the flip-flop. So what is a flip-flop actually? So flip-flop is a basic device. So what is a basic device means? It is going to store a bit of information by considering the specific value, like ones is there or zeros is there, it is going to do it. So in today's class, I'm going to explain you. The first thing is that what is the meaning of the flip-flop and what are the different types of flip-flops we do have and their description. And how do we going to get the implementation of that particular flip-flop. So first thing, the flip-flop. What is a flip-flop? It is a digital circuit. But why we are saying it is a digital circuitry? Because we are going to take the combinations of zeros and ones, we are going to combine and we are going to get the output of the digital circuitry. That's the reason we are saying that the flip-flop is a digital circuitry elements. In that we are going to store a bit of information. So it is a kind of bistable multi-vibrator circuitry. What is the meaning of bistable multi-vibrator circuitry? That is there in the electronics where we are going to take two stable states. So by taking the two stable states, we are going to get the operation of multi-vibrators. So for that particular thing, the flip-flops is going to be used. So what we said just now, it is said that it is a sequential circuit and an electronic circuit element which has the two stable states, and thereby it is capable of serving as one of the bit of memory. That means it is going to produce either bit 0 or bit 1, because our digital electronics deal with either 0 and 1's combination. By considering what are all the kind of combinational circuitry we do have, like full adder, full subtractor, encoder, decoder, multiplexer, demultiplexer, all these kind of problems also we have discussed in the previous classes. So by taking these all kind of combinations, here we are going to get the storage information. How do we get the storing of that particular information? That particular part we are going to deal in the flip-flop concept. Next thing is that what are the different types of flip-flops we do have. So there are different types of flip-flop we do have, like we had SR flip-flop, then we do have JK, then we have D flip-flop, then we have toggle. So these are different types of flip-flops. As per your syllabus, you're going to discuss. So first thing we do have is SR flip-flop. What is SR stands for? Set and reset. S stands for set. Set means higher bit, that is bit 1. Reset means lower bit, that you can say it as bit 0. So SR flip-flop, in that we are going to get the two universal gates. So we are already aware of what are the universal gates. What are the universal gates we do have? We had NAND gate and NOR gate. So these two are called what? These are called as universal gates. So when you are implementing your SR flip-flop by considering NAND gate, it is considered to be the active low. So this is called as active low implementation of SR flip-flop, set and reset flip-flop. Whereas when you use NOR gate combination, it is called as active high combination. So we do have one more in that is called clock. What is that clock means? We'll give external trigger input. We'll give external clock input to the flip-flop, and we are going to get how we are going to get the output. That is going to see in set and reset flip-flop. So today class is just like an overview for you. What are the flip-flops we are going to deal in our digital electronic circuitry. It is a continuation of your particular unit 3. Okay. So in that we are going to see how we are going to deal that particular concept in our set and reset flip-flop. Okay. So this is just three parts we are going to deal in SR flip-flop. First part would be NAND gate, that is called active low. Then we are going to use NOR gates for the implementation of SR flip-flop, that is called as active high. Then we are going to pass by using the clock